meeting is recorded, and they all get posted on YouTube after once we figure out how to do the editing and stuff like that. You know how to do the sharing dance and stuff like that, Steve? Sometimes people have to end up
I
restarting.
haven't done it on this one. I assume there's a present now button, and I'll get a screen, a window, a
Hopefully.
tab.
Might as well just try it now while we wait.
Yeah, let me make sure I get the right. Where's the screen name? Get a PowerPoint. The name doesn't tell me whether it's a screen or not, so that's kind of confusing. It says share an application window, but I don't get a window name. I get, this is strange.
No rush, take your time.
Yeah, give me 1 second to try to do a little troubleshooting here. Oh, there it is. Okay. And all right, start, or did you want to?
Cool. Yeah, let me just remind real quick. Well, once now you got that set up, let me do my homework and remind people to sign in the document, drop the link into chat and all of that stuff, and then let you kick off. Yeah, so here's the agenda doc. I just dropped it into the chat. People should have access to it. It is March 3rd. Please sign in here. Kim is the only one that signed in. Yeah, and the only thing on the agenda today is this Notary V2 presentation and discussion. So I had other topics there to cover at the end if we have time, and then we will turn it over to Steve. Introduce yourself and jump in, Steve.
Yeah, hi. So thanks. This is kind of a last minute but a well-timed discussion. So thanks for having me. So I work at Microsoft for the container registries at Microsoft, which includes our ACR content for customers to use on Azure, and MCR for how we ship our software as a Microsoft as a software company, not just a cloud. So that kind of brought some interesting questions to us. Is how do we ship software in a container and have it pulled and run on other clouds? Because we like to get revenue for our software to run on other clouds as well. That's fine, or on-prem or wherever. But how do we gain trust in that? And, or not we, but the customer, sorry, we as users. So the Notary V1 stuff, or Docker Content Trust as it's known, was, Docker did some amazing things, and there's some places they didn't get a chance to really finish, and this is one of those. There's challenges with Notary V1, which we'll talk about, and our goal is to make Notary V2 the answer to be able to move signatures across all clouds, and we'll talk about that in detail. So as part of that, as you heard me talk about that, you'll see that it's really our need, even as Microsoft, for this to run on all clouds. So that's why we've been going through this process to have it part of an open standard that any registry can run. So so if you kind of were to sum it up, what is it? It really is a mean assign artifact. And what I mean by artifact is we can put anything in a registry. And all major clouds and registry projects also support artifacts now, where you can take this infrastructure with all the VNets and security and availabilities and all the IDs and store other content, including VMs in it. So you want to be able to put these artifacts in a registry, and we want our users to have confidence in the content they consume is the content that was produced from the authors you trust. So that's kind of our headline, if you will. I made it up yesterday, so we'll see if it sticks. And we want to, like I said, we want to make it available in any OCI artifact registry, and we want to make it easy for the signatures to travel with the artifacts. Of course, we're talking majority of images, but there's a lot of other things in theirs as well. To get a feel of the workflow, we kind of paint a little picture of how we're thinking about this. So we have this Wabbit Network software company, right? They make some network monitor software, and they have a build system. in that build system, in their complete air-gapped private environment, having nothing to do with anything on the internet, or maybe it's on the internet, doesn't matter, but it's their private environment. They can create images, they can create an SBOM, whatever that means, and they can include the source as a distribution for like GPL source kind of things, and they can even wrap it up as an OCI index, so you can get a collection of stuff. This is all local. They didn't push it anywhere yet. They built it, they test it, and then they can sign it because they want to be able to say this is the stuff that Wabbit Networks produced. Now, on the other side of the range, we have this Acme Rockets company, and they're trying to build rockets to chase the wascally wabbit. They want to consume some software, and they've never heard of this company, but they want to be able to know that the software they bring into their environment is trusted and is sound, so to speak. Now, the problem is they don't really know of Wabbit Networks. Small company, that's fine. There's lots of great companies out there. So they'll go to Docker Hub and say, look, I'm looking for content here. And Acme Rockets has a policy that says they'll only allow software to come in that's signed from approved vendors or Docker certified content, let's just say. So Wabbit Networks, they can push their software to Docker Hub. They can work to get into the certification program, whatever that means, right? That's the point, is we're enabling the business opportunity and the trust. So Docker decides that they're going to certify some content, and now it passes Acme Rockets' trust list. So now they can find that content and bring it into their environment. And one of the things we want to enable is that on import of content, does it match a set of signatures? Does it match a set of keys? So in this case, Acme Rockets might say, I don't know who Wabbit Networks is, but I trust Docker Hub, so it's allowed in. Now, once it's brought into the Acme Rockets environment, we want to be able to say it was scanned, it was reviewed, it's been stamped. And the analogy here that I've been following is you're going into the airport when we used to do that. You have some ID, you've got a driver's license, a passport or something, and you present it to the security guard, the TSA agent that's there. Now, they're not going to go and look to see if your passport, all the documents you use to get your passport. They're not asking for your birth certificate. They're not asking for all those details. They're assuming the passport that you got is valid. They double check it's valid by scanning it, basically checking a revocation list. And as long as that's good, they will then take your boarding pass and stamp it with Agent 22, whatever that means, right? So that's effectively what we've done here. Is Acme Rockets now checked that software as it came in. They've stamped it with their stamp. And now as that software is roaming around the terminal, as you walk in, if you get on the plane, they don't check your passport and driver's license. They look at your boarding pass and does it have the Acme Rockets stamp on it? And if it does, it's allowed to be used. So there's that multiple lines of defense, but it's got all the lineage of what happened there. So if there's a problem, and I don't know, the TSA agent's working for the deep state or whatever fun conspiracy you want to make, you can go back and double check, and it's like, you might have been working for the deep state, but it turns out those signatures were valid, so everything's fine. Now, Acme Rockets now wants to deploy this software. They'll create a deploy script, whatever that means, Helm chart, pod spec, some other container deployment script, Terraform, whatever. And they sign that also. So now you have some kind of container host. We'll say it's Kubernetes, doesn't really matter. And it's got some kind of policy manager. Let's say it's OPA or Gatekeeper. The idea is that you can do a deployment, and on the deployment, it can see the deployment, what's being referenced, and says, well, is it signed? And we want to do this in a way that kind of a non-Trojan horse kind of way. We want to be able to query the registry for the artifact that's being asked to be deployed. And it could be deployed by the digest or the tag. It will go get the signature. And if the signature matches one of the keys that are approved, in this case, the Acme Rockets key, then it will go and get the image and bring it down. So there's that kind of multiple lines of defense. And if it's good, it's deployed. And if it's not, it fails. So that is part of the the workflow that we've discussed. And as with many software projects, there's lots of great designs. People love to start slinging code, and I know what this is. Here's some code, and look at my code, and look at this design. And what we found is there's lots of great designs. How do you judge one design versus another? So we went back and said, look, let's get a list of requirements that we can agree to. And then we're not arguing over the elegancy of a design. It's, does the design match our requirements? So like I said, the first thing is we wanted to solve some problems with Notary V1. And that is when I push something to a registry and I pull it, if I pull it with or without signing or content trust or notary enabled, I should get the same content. And that's not the case with Notary V1. So we want to make sure they're co-located and secured in that registry. It's got all of the authentication and certification. And another piece of this is the ephemeral clients. We saw with the SolarWinds exploit and others, having a build machine stick around for a long time can be problematic, right? If I can get on that machine on Monday and it's there all week or for many months, booyah, I own that machine. If it has to get built an instance every time, that certainly makes it harder. Now you got to get into the infrastructure that knows how to provision that VM or whatever that client is every time. We want to get rid of trust on first use, because trust on first use says if I injected something bad, now you've owned it from first use forward. So we have to have an implicit permissions on acquiring keys and so forth. As I mentioned earlier, we want to make sure these work across all registries. From a pure business, this is required. And quite frankly, we see our customers are multi-tenant, multi-cloud scenarios. And as you saw through that workflow, there's multiple signatures that got attached to that same artifact. Wabbit Networks signed it originally. Docker Hub added another one. Acme Rockets added a third. And you can imagine fifth, fourth, fifth, sixth. We don't see hundreds, but there's multiple signatures that can be added to it. Multi-tenant, multiple cloud providers. We want to make sure that we're not trying to do, I don't want to say not trying to key manage. We're not trying to store keys in a registry. The registry is great for what it does. And there's great key vault providers available, and we'll integrate with those. We're not going to try to replace any of those, whether it be a cloud provider or a HashiCorp for open source projects or whatever. Air-gapped is not just the submarines and oil platforms. We've all seen our customers that were working great on-prem in their private network. They want to lift that into the cloud and have no public access, no ingress, no egress, no nothing. So it's not just these secure clouds. It's literally they want to create their environment. So we need to make sure that these signatures can move with the artifacts into air-gap environments. The keys can be acquired and so forth. Usable is pretty important. I like using the analogy, you can have a really super safe door with 20 locks on it and magic crypto keys. And if you've got to walk through it a lot, user's just going to hold the door open with some piece of wood or a brick, right? It has to be a very usable fashion. Super secure, unusable, not used or bypassed. We've got to find that right balance. That's always very important. So as I mentioned, Notary V1 was a good attempt. It started, it gave us a lot of information to work with, but it didn't meet these requirements. And we have aspirations that we will. The other thing that I get asked a lot is compatibility with Notary V1. We actually don't see a lot of usage of Notary V1. We see people trying to make it work because it's really the only thing, it's not the only thing, but it's one of the few things that actually works across multiple clouds. But it doesn't meet pretty much any of these requirements. So we're not promising any compatibility. And we kind of use the bar that if it's not super simple to sign with V2, then we failed and it's irrelevant anyway. So that's kind of a way to think about it. This is kind of broken out into three major areas of focus that we've been taking in the team. One is obviously defining what exactly is a signature. And we have a pretty good form of that today. Then it's great to have signatures, but how do you get them to go with the content? We thought about making registries know very specifically around signatures, and we just didn't think that that was a very good scalable idea. We went through this when we did the OCI artifacts approach, where we were trying to add Helm capability specific to a registry. And before we could even finish thinking about it, we were already asked about Terraform and OPA and CNAB and I don't know, a bunch of other types. And we didn't want to go chase each one. if you think of a file system, on your computer, it doesn't know about the different types, right? You can save any file you want, make the extension anything you want, whatever, however you register with your operating system, what the thing is. The operating system doesn't know anything about it. It just knows how to store stuff, and it knows how to link stuff too. So that's what we've really designed here. Is a signature is just another thing that's going to go in a registry, and we'll talk about an extra piece of that. And then, of course, key management. We're less worried about the signing part for private key management. And then that companies already have great ways to do that. In fact, some are super secure, and and others, it can take a little more of a trusting model. But that we're not as worried about it. We're more worried around the consumption. So how do I if we're not going to do trust on first use, how do I discover what the key is so I can get it? So we broke down the pieces of the projects that we're working with here. Obviously, there's the registry that's going to store all this stuff. We have the artifacts, whatever that thing might be. We have our signature. We'll have some kind of NV2 client, which will more than likely be a set of libraries that will have a client that basically implements libraries. But we want those libraries to be able to be implemented in all the different container projects or all the artifact projects. And then we have an ORAS client, which we use as part of this also, which again is also another set of libraries for working with registry. And ORAS is just OCI registry as storage. Now I'm going to go do a demo, but before I drill into the demo, are there any questions that anybody wanted to ask on that framing? Okay, just get to the demo already. All right, so what we have here, what I'm going to do is I'm going to walk through a bit of the walkflow that we had in that, and this demo is the demo steps are actually up on our in the NV2 site. So I'm just going to walk through this. Basically, what I want to show is the well. First, let me just start with how do we have this mocked up. So what we've done is we didn't actually change the Docker client yet. What we've done is we've taken advantage of the plugin model. And if you notice, there's two plugins that we've added here, and they're captured on that page that I'll show later. And there's a Docker generate, and there's an NV2 plugin. And those both will enable us to do this experience. So if I say Docker NV2 Notary, you'll see just a framing of a couple of commands that we use. Now, instead of having to type Docker NV2 every time, I'm just going to alias this. So now I can say Docker Notary and it'll be fine. And then the other thing I'm going to do is not have to type the long register. This is the image name that I'm going to be signing and pushing and pulling. So it's just the registry name, the image, and a tag. Right. So that's the main thing there. So we'll start with in the build environment, right? This is some ephemeral client that we're saying, and we're just going to do a build. And if you say it's an ephemeral client in a private network, then how's it getting out to GitHub? So I skipped the clone part, Anyway, point is we're building an image. There's nothing magic about it. It's just a plain old image. Now, the next part, as I mentioned, is I would want to acquire these private keys. Now, you could say the ephemeral client might have been provisioned and then knew how to go reach out to its key vault with a security token and acquire those. So for the point of this, I have actually already have the keys on the machine that secure handshake has already been done. So let's just make some room here. So the next thing is I will turn on Docker Notary and enable it. So right now there'll be Docker NV2 Notary enabled, but we're shortening it. And then I can just simply sign it. I can sign if I can copy paste. So all we're doing is taking Docker Notary sign, use the Wabbit Networks key, the cert, and sign this image. And if we look, we can see that it is part of this flow. Because remember, I didn't push anything yet. I'm still working completely offline. And today, the generation of that manifest is kind of built into the push scenarios. But there's code that knows how to do that. So we've basically extracted that, and it exists in the NV2 client today. And I could cat out the signature. Oops. And that's a JWT, and we'll go into the signature details in a minute. And if I wanted to look at the manifest that we've actually signed, this is the manifest for that net monitor image. I've purposely kept it small. It's a single layer. It's basically just Alpine. It's a single layer, and it's got a media type. So there's basically 2 blobs in it. This manifest has it's got digest for the things it references, and the manifest itself has a digest. So there's digest upon digests. That's what we're actually signing. Okay, so now that we've got that, now I can finally push this to the registry. Now, because we've put the NV2 client into this workflow, what you're seeing is it pushed the image, it pushed the signature, and then it linked the signature with the manifest. So that's the important part, because we don't want users to be changing their workflow to have to think about signatures per se. Like, we don't want them to query a signature. They want them to query the thing they're trying to deploy or use. And then the workflow knows how to get the signatures associated with that artifact, in this case, an image. So that's the important right there. All right, so now let's imagine we're on a different machine. Actually, hold on. Docker images. So, of course, there's our image there. And if I ran it, we'll see the great elaborate code that's in there. I guess I could have said image, and we could say, so basically all it does is ping. There's this great monitoring thing. So in there, I've just got embedded ping as the entry point, and I pass it a domain, and off it goes. So great, my image works. That's fine. Now, let me get rid of it. And I'm also going to get rid of any of those signatures. So this is effectively another machine, right? So where did I do that? Cat. Anyway, trust me, the cat, I won't go back there. So now this machine has no images, no signatures on it yet. So I'm going to say Docker pull image. So it went and looked for that image, right? So that's what it went to go look for. There's nothing else there about a signature. And it goes and looks for, it goes and finds the digest for that. And then it asks the registry, are there any signatures for this digest? And it computed the digest based on the tag, because we signed digests, signed the digest of a manifest. So it found one signature, but when it looked in the configuration for where it should find keys, it didn't find any. So it did not pull the image. The pull failed. The way that the current configuration, right, this is just part of the prototype, is we've got a config file it's under Docker, it doesn't really matter. There's an NV2 JSON file. Notary is enabled. And then here is the location of where the cert is. So I happen to have the cert location here, and I'm running it locally, so it's insecure. So if I run Docker pull again, actually, let me just clear this out. Now, because I have the signature, it said found a signature, found a valid signature, and then it notices where it's the signature, the image originated from. It's went and looked at all the details. So it says, look, I found it. It's got a good signature. I'm going to pull the image. Basically, it hands it back to Docker and says, go. And now I have that image here again. So that's basically the demo at that point. That demonstrates pieces of this workflow. Yeah, go ahead, David. Was it David?
So it looks like the signatures are being maintained separately. So you could rebuild the Docker image and verify that it's identical without having to muck with or deal with signatures because they're embedded in. Is that correct?
Not really.
Not really. Drat. Okay.
Because here's the thing. So I know there's the repeatable builds model, and I love it. And right, so there's no conflict here. There's no conflict in concept. The problem is the way digests are generated is they're generated on that content.
Sure.
In theory, if you built the exact same content on the exact same machine and every package you pulled was the exact same state, in theory, that would generate the same digest and manifest. in practice, when you've gone that far to really do a full Docker build again, assuming you've done pulling all the content, like if you do Docker build of the same exact content over and over, you're right, completely valid. What the Notary V2 model is it's signing the digest of the manifest. So as long as the manifest is the same, and the layers that it references are the same, you're good to go.
Well, if you're pulling in different components, then it is different, and it should be. It should produce a different result. But I was just checking about the signatures are separate, and therefore, if it's repeatable, there's no problem. And if it's not repeatable, well, it's not repeatable.
Yeah.
You're not creating a new repeatability problem.
No, we're not completing a new repeatability problem. But we haven't spent enough time, to be fair, thinking about how the repeatable builds will merge with this. I think the repeatable builds will have to probably lean into more to the SBOM model to explain, like, is the SBOM that's generated, including the compiler settings, right? All those different pieces, are those exactly the same? And I'll talk a little bit about SBOMs here in a moment. So, what are we signing?
As a quick note, people are actually talking about that within the SBOMs, including compiler flags and so on, because of that very issue. So
exactly.
It's consistent with what other people have been saying.
So, so just a quick, because this kind of leads into this. So this is the manifest for that particular NetMonitor image, and that's the digest. So when we look at the signature, we're actually signing this digest. So if we look here, here's a little more detail. It's a formatted of the signature. It gets turned into a JWT, so we could actually round trip that, because the whole canonicalization challenges that we keep hearing about. So we have cert references. We are focused on X509. There's the OCI descriptor of the artifact, and that in this case happens to be a Docker image. That could be a Helm chart. It could be other things. We'll talk about that. We've also included, this is an experimental part of this that we're looking at. Basically, when you want to validate a signature, validate an artifact, right now we're thinking there's two levels. One, is the key valid, right? So the public key that I'm comparing against the cert, is that valid? That's good. So let's say that Docker Hub didn't re-sign the image, and Acme Rockets didn't re-sign the image, but they followed the best practices of don't depend on public content in your environment, right? You should not have deployments based on public pulls. Put them in a registry that you own, that you have control over. It's in your network control and not subject to the fun of the 8 million connection points in the internet. So you pulled it into your private registry. So this one, I'm actually going to deploy from registry.acme rockets, but this particular content is signed from where it was originally pushed to. So I can make a choice and say the Wabbit network signature is good, so I trust it, but I don't allow anything to be deployed from anything other than the registry the registry that it's signed from. So this would fail that second validation if I wanted it. If I have an additional Acme Rockets signature on it, then the references would be registry.acmerockets.netmonitor, blah, blah, blah.
I'm very sorry, Steve. Can you go back and say that another way? Because I'm not sure I got it, and I feel a little dumb right now.
Yeah, no, this is one I realized.
There's a subtlety I'm not understanding, and I want to understand.
And to be fair, I haven't practiced this a little bit better to do the talking points. When I want to validate a signature, the first thing is the public key still valid? Was it revoked? And is the content signed with that key? And is the content, signed against the signature? So that's the standard things we all think about. So that's the kind of table stakes. There's a second piece that we see customers saying is, I don't want to deploy content to this cluster, to this host, unless it comes from specific registries. They want to block things coming from Docker Hub, from Quay, from GCR if it's not in Azure. In Azure, in Google, you should be blocking stuff coming from ACR for that matter, right? Put it in a customer's private registry. So the point is, and it's not ACR per se, it's the customer specific registry. So what we're doing is playing with the idea that the CNAME of the cert could be required to match. So this example,
Are you, first off, are you following why it's important to put it in a private registry, David?
No, it's much more. I was trying to understand
Okay.
its difference. So if I understand you correctly, Steve, it's I know who it's from, but I don't want that something from that source coming in.
or
Okay.
it doesn't, I only want to allow things from my source.
Okay, that's fine.
So
Got it.
we'll play with this more. This will get more clear in some of the open demos in the future. So then there's details of the signature itself. All right, so that's, for the sake of time here. So Dan said make sure I leave time for questions. So where we're at is prototype. What I just demoed was prototype 1. We did that last September. We completely hacked the registry to make this work. We took CNCF, what's now CNCF distribution, and we basically jacked in some stuff related to how storage gets done and the way we do the linking. Now that we've proven this model works, we're basically been focusing mostly on getting the changes to registries to support what we call linked artifacts. So that's, and this is kind of a little intertangled there. So prototype 1 is done. Prototype 2 is now focused on, first, how do we do the right integration with something like Gatekeeper with policy managers? And we're looking for people to help us out to actually dig into Open Gatekeeper and test how does NV2 interact with Notary V2 interact with something like Open Gatekeeper. And we're now, like I said, formalizing how us as registry operators would actually be willing to ship this. Like nobody would be willing to ship what we did for the prototype 1, the hacks we did to the registry. Now that we know the model, we're going to be doing some changes to CNCF distribution and the OCI artifact spec to enable that. And that's what you see here in the second bullet. And the details of that to get a sense. So today, a registry knows how to take a manifest that references a thing, the netmonitor image, and says that manifest has a config and 1 or more layers. There's this downward pointer kind of thing. But signatures are the opposite. So if you remember, we said we cannot change the digest or the tag of something we want to deploy. David's team has a deploy script that says deploy netmonitor :v1 or deploy netmonitor at SHA-1234. And that deployment script shouldn't change just because I add a signature. So we need to be able to add content to a registry and says, by the way, I am enhancing this other thing, and multiples of those. And those signatures individually must be immutable. We don't want to go and have to keep on updating a document in the registry that says, here's another signature, and there's collision and contention. And then there's an SBOM document, right? That's kind of details, which it also references the thing, which, by the way, it also has a signature. So you kind of see lots of new things of new references pointing up. So that's been the changes we've been doing with OCI artifacts to enable all of this. The last picture is simply this model, this interactive model of doing prototyping has been really key. Because we have key management experts, because we have registry experts, because we have artifact experts. And if you've ever had a chance to be in Sagrada Familia, you've seen that one of the ways Gaudi did this was to get all the trades to work together. Is he didn't build a master blueprint. He built models where the different trades can look at it and see in a 3-dimensional way how they could interact. That's been critical to how this development has been working, is once you can see and touch it and play with it, we've been able to see where different people would plug in. So there's obviously going to be a spec coming out of it. I touched a little bit on the signature spec, but we wanted to experiment with it and make sure that the spec is actually implementable. So that's where we've been at. This presentation itself is located there. The Notary V2 folks, we meet every week on Mondays at 9 a.m. Pacific time. I've got Justin couldn't make it today. Usually we co-present these. And that's the talk. So questions, comments, thoughts?
I have a question about the schema for the manifest. Is that based on work that this particular project is defining, or is it looking at other industry efforts to define standardized schemas for a manifest?
Oh, so which manifest are you
so,
referring to now?
For example, the ISO defines something called SWID tags. There's something in IETF called CoSWID, which is just a CBOR JSON encoding of the ISO definition, which is an XML encoding.
Yeah, no, it's a great question. Let me put some context to that, because what the manifest is a generic word. So what I'm talking about here when I say manifest is, how do you persist something in a registry? And registries have a well-known format for how they interact with things. So this is not meant to be an SBOM manifest. It isn't meant to be an image manifest or anything else. It's just, how does this infrastructure that we've all implemented, the distribution spec, know how to persist things? How do you tell a file system, store this collection of stuff and let it do its defragmentation kind of stuff? So it's very, very coupled to how a registry works. And a registry has blobs. Well, actually, let me show this spec here if I can switch back over to it. So this is the PR for the new manifest that we've been working on. And what it does is where do I have it? I wasn't prepared to talk about this, but that's fine. So an OCI image manifest has blobs, and which is the config object is stored as a blob, and the layers are stored as blobs. And then the manifest is the other objects. There's really two object types that are stored in a registry. What we're doing to support, right, so we can point down to things. So even a signature has a config and a blob to represent the signature. An image has configs and layers. What we're saying is, what we need to be able to just scroll forward, we need to support this dual model. So what we're saying is this is the one. There's a third manifest. There's two manifests that registries support today. A standard OCI image manifest, which is what you do for a single Docker image. If you have what's called a multi-arc image, where it might be Windows and Linux or ARM or whatever, you can actually say, Docker pull hello world, and the client, wherever the host is, will figure out, what am I? Am I Windows? Am I Linux? Am I ARM? Hey, registry, by the way, this is what I am. Do you have my version? So that's the second type of manifest registries know how to persist. What we're adding is a third manifest that's very registry specific, that says, here's the same config. Here's layers. We've renamed them blobs because layers is specific to the way image layers works. Everybody wanted to rename it blobs anyway. So this is just a rename of what's already there. But this is the new element that says this signature points to the net monitor image. So that's kind of the level of detail when I talk about manifest here. How somebody wants to persist an SBOM, how somebody wants to persist a turn or anything else of that matter, that's just content that gets stored in the blob. Does that make sense?
Yeah, it looks like it's sort of pieces of the solution where this manifest structure has a digest, but the signature isn't defined in this structure directly.
Correct.
Yeah.
What we're doing here with this OCI artifact manifest is we're enhancing the way registries can store stuff, right? We don't work with the file system to know how to store, PowerPoint documents. The Office and PowerPoint team look to the file system team and say, hey, how do I store stuff in it? By the way, I've got a new extension. Who cares? Go for it. This is enhancing the way registries can store stuff that just happens to be this reference stuff, such as a signature or an SBOM. So if we look back at this picture here, now I'm using WordPress here. The WordPress image, this is what we think of today. These are individual artifacts. The idea that they can be linked together is the new thing that we've been focused on.
So in that model, the registry becomes part of what we might call the trusted computing base of the set of things you have to trust as a verifier in order to accept that information. Essentially, in order to trust the signature, the digesters spread around, so that essentially pulls these other things into the TCB.
It's a good question. I hadn't spent enough time thinking about it. The way I would say it is, how do you differentiate whether you pulled some content from a Git repo, a file share, a blob storage, or a registry? This is really just yet another storage solution that has a way to sign the content. So as the content goes into that storage solution, the registry, and as it gets moved across registries, I can say that that content that went into this registry is coming out and going to others is the same content. That's the boundary by which we're trying to manage.
And I guess the way to make that statement believable by a third party is, providing enough context for them to essentially prove to themselves that the statement that you just made is true.
Yeah. Like, this is one of the things, like we've said, that the key will not be in. We don't believe that registry is going to store the public keys, even the public keys. We certainly won't store the private keys. But we haven't figured out what we're going to do about public key discovery, because we're not going to do a trust and first use model. But you'll have at least some element of, I'll call it two-factor auth. What do you want to call it? Two elements that have to be trusted together. So you can't just hack the registry and hack the public key. You would have to kind of hack multiple things to get that to get access. But it's a great place. I know that trusted compute-based conversations have been coming up, and I hadn't really thought about it from that angle.
Sure. Yeah. Okay.
It sounds like it's a way to verify that information is what you think it is. Whether you decide to then bring it into the TCP is a separate question. You might ask that question first. I had a separate question about interactions with some other things. You mentioned, you obviously demoed with Docker. Have you given any thought to supporting Rocket?
So the way we're thinking about it is, a registry is just storage. The registry is just another cloud file system, a very specialized, highly, we've all had to harden these, registries to support massive scale and requirements. What you stick in it, don't care. How you build an image, don't care. And that's why I've mentioned is that we want to make sure that the Notary V2 libraries are available, whether it's in the right language or not, we'll see. But there'll be a spec. We'll have some libraries for some, core languages that we think will need mass adoption. And then the idea is, you go build it into your thing that you want. Whatever you want to store in the registry, here's the way that you can do it. Party on. Where we want to really enable those and not get into the details of it.
Just one other note, that Rocket has been officially deprecated for a few years now.
I didn't want to point dirt on the
I'll say it.
I
Container
kind of took it as more of the abstract of,
Fair enough.
Yeah, Container D would probably be the better term, I guess, at this point, for something non-Docker specific.
And we're hoping, when I mentioned, we're not only just trying to get this working with OPA. If we can get it working with OPA, then that's the next part of the validation. The next part of it will obviously be, okay, let's go get this in Container D. Let's go get this in the Docker client, into BuildX, and in all of these Builder and all the other different things, into Helm, into into Singularity, or whoever wants to put stuff. We want to be able to enable all of those types without knowing all the details. I mean, the way I think about this is, if you're building a large scale project, because there's a couple different business models, right? If you're doing customer intimate, then you know all your customers and they know you by name, you're taking them out to lunch, whatever. In any kind of scalable solution, you can't possibly know all your customers. So this definition of success is, I don't know them all. I might know a few, I don't know them all. We want this to be so successful. We don't know all the different types that are using it. So we have to think about that kind of scale of the APIs and the capabilities that we're enabling. Are they generic enough? At the same token, we're not trying to boil the ocean, right? Like, we're not trying to replace every last solution that's out there for persistence. We're just trying to say, there's any new artifact. It's kind of hard. There's a separate talk I make around the OCI artifacts approach is, do I need yet another storage solution? Why not just use this? So that's kind of a different conversation. actually don't know how much time we were supposed to do. Was this a half an hour or?
You had the whole meeting basically. I don't think there's anything else on the agenda. So
Okay.
nothing else got added.
Steve, have you thought at all about transparency for these signed artifacts? Like any sort of transparent, like binary transparency or artifact transparency system?
I don't know that meaning. Sorry.
Okay. Yeah, it's something we've talked about a bunch in the group. It's sort of a generalization of the certificate transparency stuff that exists for web PKI, where effectively for a browser to trust an issued certificate, you need to staple a signed assertion from these third-party transparency authorities, basically, and their job is to maintain a record of every certificate that was ever issued. So it's addressing a detection. It's a detection mechanism. So suppose a code signing key were compromised, the owner of that key could monitor this transparency list potentially to detect any malicious signatures.
So this is an example. I'm standing on the shoulders of other giants. Maybe I'm the general contractor, and there's a bunch of our key management experts, and it sounds like this is part of our key management, in areas. So I definitely encourage you to, help and contribute. I'll bring it up, but the idea is that I would have to defer to them to answer your question.
Thank you.
And, to that sense, we'd love more engagement, whether you can attend the meetings on Mondays. We record them all. They're posted up on YouTube. There's a hack doc you can get to on those. There's issues that we're tracking. I mean, it's a standard open source project. So we really, we're trying to make sure we're addressing all of the needs that people have while maintaining our scope so that we can actually ship this thing. But what you described sounds very much of what, how somebody would just manage the keys and so forth. We're not trying to reinvent a new key management system. We're trying to leverage the existing ones.
Hey, Steve.
Yeah.
Quick question about the manifest format. So is that something like, is there an existing format that you're just extending?
Yeah.
Okay. All right. Because I was thinking that there's, we could just think of that as another type of software bill of materials. But that's what you're saying. Yeah. And anyway, because the software bill of materials is building also this concept of links to external components, but
it's very, very different. Like this is in this group, it's probably way too much detail to even talk about. It's in the group of people that are running registries and building artifact types like tools that would interact with a registry. It's really important to them. Outside of that, it is not usable for things outside of that. Like it is a very tailored thing for how you persist things into a registry. Unless you're authoring artifacts, including the SBOM, to be fair. And it's not the SBOM format itself. It's when you want to save whatever you guys define as your schema. And as long as you can persist it as some files or blobs, then when you want to tell the registry to save it, there's some internal GUI that says, by the way, this is how you tell the registry how to store it. It's not meant for anything outside of that.
Okay, I think I understand.
Just everything's named manifest.
I guess one thing to think about is whether or not you have to recompute digests in order to put it into an external format. Since you essentially have an internal format with a digest that matches when you export out of the registry into, say, an SBOM or a SWID tag. If you could reuse those digest computations some way, that would maybe be a more efficient way of doing things in the big picture. I don't know if that's reasonable.
No, it's possible. I mean, look, the thing that we did with registries in this approach is you can store anything in a registry and you can link it to other things. So one of your content types could be the signature that you need for your thing. The notary signature is just saying that when it's as it's within and across registries, the gazintas and the gazantas will always match, and you can verify that. If you want to put other content that happens to be the key, like, I've got a package and it's signed, sealed, and delivered, whatever, and I can verify it before I even put it in a registry, right? It's got a separate thing. Then there's this part where it goes onto the truck and it goes through registries and it gets to the other end, and it's going to leave the registry and have a life outside of it. We want to make sure that you can put the thing that you're verifying independent of that in the registry as well. We're just putting a secondary stamp that while it's going through the registry and across registries, there's a seal on it that says this is verifiable. That's some of the stuff that in the SBOM working group that Kay's been working on is I've been trying to keep an eye on how does that handoff happen? Because what you're kind of getting at is, at least what I'm hearing and trying to make sure I'm accounting for it, is you're going to create SBOMs and you're going to sign those completely independent of registries, right? You want to make sure that when I look at this SBOM, it's true, it's accurate, and I can trust it. That needs to be done before it even goes into a registry. It just so happens to be able to ship that SBOM from point A to point B. We want to make sure that the seal on the package doesn't get broken. So that's an extra signature on it. If you want to use that signature as part of it, and that's good enough, that's great too, because to your point, the manifest is a way to kind of compute that. But I'm trying to be careful of saying, look, we're not trying to make this manifest live outside of registries. It really is meant to be a definition of persistent format. If that makes sense.
Yep, got it.
But I am curious to think about that. This is something I have been trying to figure out, is things that are signed separate from registries. How do these things interact with each other? And there's some interesting stuff happening around a signature of expanded content, by the way, and how would we rationalize that?
So the sort of really brief tutorial on SWID tags, they essentially use a model where they represent a file system in their schema. So you can essentially compute a digest based on a pointer into a file system as sort of identifying the thing that you're digesting. And that works great if you have a typical Linux file system structure, but I don't think it works for registries. But it would be an interesting exercise to walk through that to see if there is a way to do that. And then you'd have a sort of an external representation of an industry standard schema for software that can point into a registry. And if it makes sense, there could be some performance optimization accommodation for the digest that's already there to just copy it instead of recompute it. But maybe you want to recompute it for security reasons. I don't know.
That's a good question. The thing that I've been also wrestling a little bit with is we're seeing registries store. There's different optimizations in how you compress and store stuff in a registry. Like today, we use tar.gz for the most part. The OC artifact approach says don't care. But if you look at some of the stuff we're doing with our Project Teleport in Azure, we decompress the layers. The signature is based on the compression format. So we were looking at other ways of how could you sign the content as it's expanded, because the kind of like when I start with the content outside, I put it in a registry, I get it out on the other side. In Containerd and others, the layers are expanded. How do I know that expanded layer didn't get messed with? So there's some interesting things there that we're trying to figure out is how does that get accounted for as well? Especially if registries are going to be storing multiple compression formats. There's some talk about tar.gz and various other format types that might be project performance specific that we're trying to figure out how did we store that. So the right now there is a standard that an artifact is compressed and put in a registry, and we're trying to make sure that's at least covered. And then as these additional scenarios come up, we're trying to figure that out as well.
Okay.
These are great questions.
Well, thanks, Steve. And you sent the link to these, right? Let me find it and make sure I can get them into the agenda if possible.
Yeah, here. I didn't do you brought up I'll put the links in the Google Doc that you mentioned.
Perfect. Yeah.
I figure I
Awesome.
shouldn't be editing a Google Doc while I'm presenting.
Yeah. Awesome.
Well, thank you.
All right.
Really great. Thanks for the opportunity. Been trying to keep up with all the stuff that you guys are doing here. There's a lot of moving pieces. So if you see something you don't see covered or think we need to adjust or the problems, like as somebody working on it, it's always great to hear. Great, that's great. But I really want to hear about the things that are challenging because that's the stuff we can go fix. So appreciate the feedback. With that, I'll let everyone get on with the day.
Yeah, thank you. We'll get the recording
Thank
for
you.
this uploaded and put on YouTube and sent out and all the fun stuff. So thanks for doing this.
Thanks, Steve.
Thanks, folks.
Take care.